So let's do another one-dimensional problem. Let's now take our book up to the top of the building. We're really abusing this book, but that's all right. It's for the sake of physics. Let's throw it upwards at 3 meters per second. We're going to throw up at 3 meters per second. No, we're going to throw it upwards at 3 meters. Okay. So how do we do this? All right, first, as always, set your positive direction, draw your pictures, identify what you know, what you don't know, write down your equations, blah, 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 blah. So some of you might still be at the point where you're saying, well, do I set up as positive y or down as positive y? Well, first of all, it just doesn't matter. Doesn't matter at all. Doesn't matter the least bit. Set it whatever you like, and then make sure that your variables have the right signs in front of them according to where you set your positive directions. So let's just, for the heck of it, because we already did before, set plus y in the downward direction and plus x in the horizontal direction. So there's our directions. So now we're in 2 dimensions. We got to set both plus y and plus x. We got to define plus y and plus x. Okay. I just drew the ground in there to differentiate that from an axis. Okay. And so then we go ahead and indicate other things. We can indicate them on the picture. We know it's accelerating down at 9.8 meters per second squared. Don't know what else we need to indicate on the picture. So let's go ahead and write out our variables. Actually, let's write our equations. Okay, I wrote my 4 equations of 2-dimensional projectile motion, even though you might recognize this is actually just a 1-dimensional problem again. Delta y is equal to plus 30 meters because I defined down as positive. A sub y is plus 9.8 meters per second squared. I'm just going through my equations. I'm looking at the variables. I'm not going to check them off as I go. T is an unknown because this is a new problem. V0y is negative. Now this will mess some of you up, right? Minus 3 meters per second because we're throwing it in the upward direction, but down is plus y. Vy, the final velocity, we're looking for that in part B. 1, 2, 3, 4, 5. There's our five variables. Delta x, v0, x, and t, we actually don't care about those because there's no motion in the x direction. We're then going to say, okay, for part A, okay, just if you need to pause just to think about everything I just said, please do. But I'm going to go on. For part A, how long does it take to get to the ground? So we can use, it's really the first equation is going to be the best equation to use. Delta y, whoops, going to use plug into the first equation, plus 30 meters is equal to 1/2 times plus 9.8 meters per second squared times t squared plus v0 minus 3 meters per second times t. I didn't leave myself much space there. Okay, so how do we solve this? It's going to be the quadratic equation. So we got to plug it into the quadratic equation. And I'm just going to go ahead and do that offline and give you the answer, which you should do for yourself. So you get 2 answers, 2.8 seconds and minus 2.2 seconds. And I'll let you think about that for yourself, why the correct answer is 2.8 seconds. Well, minus 2.2 seconds is before we ever threw it. So that's why that one is not. It is if it had come from the ground, it's how long it would have taken to get to the top of the building. But anyway, okay. 2.8 seconds. That's the answer to A. Then for B, the answer to B, what is the velocity at the ground? We can use either the second or the third equation. Doesn't matter. Which one is best to use? I might say that the better equation to use, either one you can manipulate, but the better equation to use might be the third equation because it doesn't require your answer to part A, just in case you made an error in part A. So Vy squared is equal to V0y squared, 3 meters per second minus 3 meters per second quantity squared plus 2 times 9.8 meters per second squared times delta y plus 30 meters. Make sure your units all turn out, which indeed they do turn out to be meters per second once we take the square root. And so Vy is equal to, do the math, and don't forget there are 2 possible answers. Vy is plus or minus 24.4 meters per second. And indeed, when it's at the ground, if we had gone back in time to the 2.2 seconds, Vy would have been upwards and it would have been minus 24.4 meters per second. But in this case, it is positive. It is downwards. 24.4 meters per second is the correct answer for part B. Again, if we had actually started at the ground and thrown it up, we would have had to throw it up at 24.4 meters per second in order for it to get to where it started 2.2 seconds later. Hence the two negative possible answers. But we're talking about when it gets back to the ground is going downwards. And so the final velocity, that's what we should have drawn in our picture. Since I asked in part B, what is the final velocity, what is the velocity at the ground, I should have drawn a picture of it at the ground and shown that the velocity at that point is Vy in the downward direction. That should have been included in the picture. And so that's the answer to part B, 24.4 meters per second down, or since we define down as positive, it's 24 plus 24.4 meters per second. So that's the answer to that. Let's go to example 4. So you might guess what's coming next. That if you were following along, you should have guessed. Now we're going to throw it at an angle. But I'm going to throw it at an angle, so I sort of did the problem backwards. And what I really wanted to start with is say, let's throw it at an angle such that the x component of that initial velocity is 5 meters per second, and the y component of that initial velocity is 3 meters per second. Hopefully that makes some sense. So we're going to throw it at an angle. What's the trajectory of the book going to look like now, right? The book is going to go up and there. And so the book is going to land somewhere over here. So I want to ask 3 questions. Where does it land? What is the velocity when it lands? And again, when I ask that question, you have to know that the implication is while it's still undergoing constant acceleration, that's just the instant before it hits the ground. And what is the minimum velocity and where? So, part A, where does it land? Well, the motion in the plus x direction is independent of the motion of the plus y direction. So the fact that we threw it upwards at 3 meters per second, sorry, I thought I made a mistake. I didn't. So the fact that we threw it upwards at 3 meters per second doesn't change where it lands. What changes where it lands? The 5 meters per second to the right changes where it lands, right? So to the right, if I want to know how far it goes in the x direction, delta x is v0 xt. We can write down the 3y equations, but we already solved those 3y equations here for various variables. And so we can say, okay, delta x is equal to v0x I should have written down, is positive 5 meters per second. And so delta x is, I'm trying to go too fast. And t we already found, because the fact that we're throwing it horizontally at 5 meters per second doesn't change the y motion. So we already found that t is 2.8 seconds. T is 2.8 seconds. Or you could go back and you could solve it again, right? Breaking it up into the x and y direction, which is exactly what we did. We're just doing it backwards, right? You can say, this is what happens in the y direction, and this is what happens in the x direction, right? Part A, this is what happens in the x direction. We just treat them separately. The time is the amount of time it's the same. So we've got 5 meters per second times 2.8 seconds. So delta x is, what's that? Is that 14? 14 meters. So where does it land? It lands 14 meters away from the base of the building. I'm not going to write those words, but that is, or let me write the displacement. The total displacement is 30 meters down plus 14 meters over. Or in words, you could just say 14 meters from the base of the building, horizontally. I guess 14 meters horizontally from the base of the building. Okay, that's part A. We didn't have to do much there. Part B, what is its velocity when it lands? Again, we already solved the y direction. In the y direction, we said the velocity was 24.4 meters per second when it lands. So in the y direction, that's not the y direction. In the y direction, v sub y is 24.4 meters per second. What's its velocity the instant before it lands in the x direction? You should pause, think about it for yourself, but I'm going to give you the answer. It's 5 meters per second. Because it travels at constant velocity in the x direction. The velocity in the x direction doesn't change. So that's v sub x, because it doesn't change. So the velocity just before it lands, v, is equal to 24.4 meters per second in the y direction plus 5 meters per second in the x direction. That's supposed to be in the x direction. Now, if I had asked what is the speed when it lands, or the instant before hitting the ground, right? The speed is just the magnitude of that velocity. So the magnitude of that velocity is the square root of 24.4 squared plus 5 squared meters per second is 24.9 meters per second. That's the speed. I didn't ask for that, but just, in case you were wondering, the speed is 24.9 meters per second. The direction, we could add these two vectors to figure out at what direction is it traveling just before it hits the ground. It's not traveling straight down, right? Because it's traveling down at a speed of 24.4 meters per second. It's traveling horizontally at a speed of 5 meters per second. So its net velocity is, at some angle like that just before it hits the ground. Okay, part C. What is the minimum velocity, and where does it have minimum velocity? So think about this, right? Where is its minimum velocity? Well, so a lot of people have the inclination to want to say 0, right? It stops at the top of the motion. Aha, careful. Here's my book here, right? What happened in the y direction? In the y direction, it went up, and then it stopped, and then turned around and came back down. This is those arrows aren't really meaningful, but it went up as it traveled from the left to the highest position, stopped in the y direction, turned around and came back down to the ground. But in the x direction, what's it doing? In the x direction, it's moving in the horizontal direction at 5 meters per second the whole time. It's moving at 5 meters per second in the whole time. So what this picture really should show is at the top, its y velocity is 0. Its x velocity is 5 meters per second. At any other time, it's going to have an x velocity of 5 meters per second and a y velocity that is non-zero. Right? At any other time, it's going to have an x velocity, which is 5 meters per second, and a y velocity, in this case it's going up, which is non-zero. Right? So where does it have the minimum velocity? Right? It's got 5 meters per second in the x direction the whole time. In the y direction, it's got a positive velocity. It's got an upwards velocity on the way up and a downwards velocity on the way down. Non-zero, only 0 at the top. Vy equals 0 at the top. At the top of the projectile, at the highest point of projectile motion, is where it's got its lowest velocity. And the lowest velocity it's got throughout the entire motion is simply the velocity in the x direction, 5 meters per second in the x direction. Okay, hopefully the few examples that I did sort of got out all the general concepts about projectile motion, and now we're going to spend some time doing more projectile motion examples. That will be coming up next. What do you call a fish with no eyes?